Before we start talking about what it means to have a one-sided limit and the craziness of what's happening with this particular function when x approaches 2, I want to quickly review what we talked about yesterday for the benefit of people who weren't here or for people who just need another clarification. So we're going to look at the limit of this function as x gets closer to 1. The limit as x approaches 1. Let me pause my video and get some better graphs going on here for one hot second. Here's a picture of that same function that we looked at before on the note page. It's x cubed minus 1 over x minus 2. And it's hard to tell what's going on when x approaches 1 because my scale on the y value is so gigantic. And I'm going to change that right now so we can get a better look at this graph. So I'll make the y values go from, instead of negative 200 to 200, we'll just go from like negative 10 to like 10. And we're going to look at the limit as limit of this function as x approaches 1. So if you were here yesterday, you know that we're talking about what does the y value get closer and closer to as the x value gets closer and closer to 1. And so we can just imagine tracing along this graph, and here's where x is 0, and here's where x is like 2 way down here, and here's where x is 1. Don't really care what's happening right at 1, but just before 1 or just after 1, I want to know if the y value gets closer and closer to a specific value. And we can see that as I get closer and closer to 1, the y value gets closer and closer to 0. Now, if you were here yesterday, you'd also heard me say, in fact, if x equals 1, y equals 0, but we don't ever need to, that does not even, we shouldn't even be talking about that. It doesn't matter what's happening at 1, just what's happening near 1, and near 1, the limit's going to equal 0. I could also confirm that by taking the value for 1 and plugging it into this function and getting 1 cubed minus 1 over 1 minus 2, which is 0, over negative 1, which is 0. So I can do that both algebraically by plugging stuff in and graphically. I also might look at the limit as x approaches 0. As x approaches 0, we are interested in what happens to y as x gets closer and closer to 0. And as x gets really, really, really close to the 0 value, the y value gets closer and closer to maybe a half, looks like it. And regardless of which side I approach from, as x is closer and closer and closer to 0, y gets closer and closer to 1/2. So I would say it's a half. Graphically, numerically, I can plug in the 0 and get 0 cubed minus 1 over 0 minus 2 is 1/2. That would be the algebraic proof. That's the graphical proof. But as I try to approach 2, crazy things happen. And so that's where we have to talk about one-sided limits to help us be a little more precise about the insanity that ensues.